This is the fourth question, so let's start with the free body diagram. Okay, geographic reference, let's say north is there. Over sled with a force, I'll call it F1, pulling north, 140 newtons. And we have a larger force pulling towards the west here, F2, 160 newtons. There's a free body diagram, always a place to start. Second step, add those up for an F-net statement, and this is two-dimensional. That F-net statement is going to be a tip-to-tail vector diagram, like so, of 160 newtons, 140 newtons, and there's our answer right there. There's our net force. That's some angle, like so. Okay, so via Pythagorean theorem, F-net equals F1 squared plus F2 squared. Substitution. Therefore, F-net is equal to 212.6029. We'll have to round that off yet. Newtons. Good. Now, of course, force is a vector, it requires a direction. Let's use a tangent to find that direction. Where tangent, of course, is opposite over adjacent. So that's going to be 160 newtons over 140 newtons. The angle here, make sure you're in degree mode, 48.8 degrees. So it looks like the net force, rounded off to the appropriate amount of single digits, which is 3 of them, is going to be 213 newtons, 48.8 degrees. And looking at this, this will be west of north. West of north. Now you could also, if you wanted to, say 41.2 degrees north of west. The angle in there if you wished. Well, we're also asked with that force, how far is it going to move in 2.1 seconds? Well, for that I need the acceleration. I can determine the acceleration here using F equals ma, Newton's second law. Therefore, A is equal to F over m. A is equal to the force of 212. Let's use the unrounded version here. Newtons, and the mass was 105 kilograms. So the acceleration, pull up the calculator there for a moment, is going to be 2.0248 meters per second squared. Okay, so how do I change an acceleration into a distance traveled? Well, I checked my formula sheet, and this one looks really nice for this application. D equals VIT plus 1/2 AT squared. It starts from rest. I'll designate it that way. VI is 0 times T, all equals 0. So the formula reduces to a simpler form, 1/2 AT squared. Substitution, 1/2, our acceleration, 2.0248 for a time of 2.1 seconds. Don't forget to square it. D is equal to, run that through my calculator there. What do we get? 4.4647 meters. So the distance traveled is then to 2 single digits because of the time. This was 3 single digits, but this, because of the time is used, is going to be 4.5 meters is what we have. So we have our answer for the net force. We have our answer for the distance traveled. We're done.